So a wave is a carrier of energy. This is how we see the waves, right? That's how we see the waves. We see the waves that are traveling. You can visualize this wave traveling, but the wave travels, but the particles don't travel. Okay. When you see waves in water, you only see the waves traveling. The water doesn't travel from one place of the pond to another, right? The water remains there even after the waves have settled down. So that explains that the wave consists of multiple particles like these. Okay. These particles are water molecules in water waves. These particles just move up and down like this, up and down, up and down, up and down. They move like this, up and down like this. But their movement occurs in such a synchronous pattern that it appears that the wave is moving like this. The best example of how the particles move up and down to form a wave, you can find it on the internet at wave animation. Search for wave animation, then you can see how the movement of the particles make waves. Okay. That being said, there are two basic parameters of waves that we need to know in order to analyze waves. Okay, we have to analyze everything in physics numerically, right? So this is a wave. Let's extend it a little bit further. Okay, so this is one complete wave. This is one complete wave. Okay, so what is the wave length? The wavelength is the length, the distance between 2 points of a wave which are in phase. Okay, I'll give you the definition and the whole link to this lecture in the in a separate message. For now, just understand that wavelength is the distance between two particles which are in phase. For now, just understand that this is a crest, this is a crest, this is a trough, and this is a trough. Crest means the highest points, trough means the lowest points. So these both are crests, right? So the distance between these 2 points can be called a wavelength. We denote that using lambda. So since these 2 points, these two crests are in phase, you don't need to understand at this point what in phase means, but understand that these 2 points are in phase. So this is a wavelength. In phase means the distance of these 2 points and the direction of motion both are same. They're moving in sync. If this is going up, this is also going up. If this is going down, this is also going down. And the distance above this equilibrium line, that is also same at all times. So this means that these 2 points are in phase. Okay. Once again, this will become much more clearer if you see an animation. Now this gap, this is an equilibrium line, right? For example, this is the line when there is no wave in water. So this height, the maximum wave height, is called the wave amplitude. Okay. This is called the wave amplitude. We denote that using a or sometimes small a. That's the amplitude and that's the wavelength. There is an equation, v is equal to f lambda, where v means the wave speed, f means the wave frequency, and lambda means the wavelength. This is very important for small maths. Okay, now we will see what wave fronts are, or what is a wave front. So imagine that this is a pond. Okay, that's a pond. You see waves on the pond, right? These waves, these waves, these waves. These are the wave fronts. Okay, the definition is a wave front connects continuously all those adjacent points which are in phase. Once again, it's a very difficult definition. I'll send you the links so that you can see the definition later. But the wavefront is anything that you can see. The wavefront is anything that you can see. So this is a pond, the waves are traveling. These are wavefronts. Okay. Frequency. Imagine that you are very sad on a particular day. You couldn't pass your physics exam, and you're sitting on the edge of a cliff, thinking about ending your life. I'm just kidding. Don't do it. So from the top of the cliff, you can see the waves are coming in this direction. Okay, the waves are coming in this direction. You decide to count how many waves cross you in a time span of 1 second. Okay, in 1 second time, 1 second. So you counted within 1 second, 5 waves travel. 5 waves go under you in 1 second. Okay, this means that the frequency of the wave is 5. 5 what? 5 hertz. 5 hertz. 5 hertz means 5 waves travel a particular point in 1 second. 5 hertz means 5 waves travel through a particular point in 1 second. This hertz can also be written like this. Hertz means 1 by second. So 5 waves per second. But we don't normally write second, we write hertz. So 5 hertz means 5 waves per second. This is what hertz means.